Hi everyone, in this tutorial I would like to show you how Topologic can transfer dictionaries through Boolean operations and the importance of that or the utility of that. So as you can see here, I have created three entities: a prism right here, a cylinder, and a sphere. So those are the three nodes that have created these entities. And then I went ahead and built a cell complex out of them. So you have one entity that has several cells in it. Probably if I count them, it'll be like 1, 2, 3, 4, 5 cells. And it will tell me when I query these cells, the parents that have generated that cell. So in this case, because they have been merged, it will tell me that this cell, for example, that's highlighted in blue, is the intersection of a prism, a cylinder, and a sphere, which I think could be quite useful. So for example, if you are designing a house and you are moving spaces around, you might move a living room and a kitchen and they intersect, and it would say, oh, this space is the intersection of a living room and a kitchen, so maybe it could be an informal breakfast area perhaps. So it might be good to do this type of transfer of dictionaries. So I will show you all of that. But just to illustrate it a little bit, we can go ahead here and get a different cell. So this is the one where we are getting a different cell. And if we change the index, for example, to another one, it will say, okay, this one is exclusively a prism. It was not the intersection of anything else. It's what's a remnant of the prism, and it will display the name here. If I change the index one more time, it will say, okay, so this one is the intersection of the sphere and the prism, but the cylinder and the prism played no role in creating this part of the construction, and so on and so forth. So you can see this one, prism and cylinder, etc. So how do we do these types of dictionary transfers? So I'm going to go ahead and close this. This is quite a big definition for a tutorial, but we'll see if we can get through it. Okay, so let's get started. Also, I would like to mention that all of these tutorials or the definitions, the JSON files for the Sverchok definitions are all on GitHub. You can go to the Topologic Sverchok repository and find them. So let's go find that. So you find them here under Topologic Sverchok, and under the examples folder you will start seeing these being populated. So every time I do a video, I will also upload the JSON file here, and then you can go ahead to Sverchok nodes, create a new one, and if you open up the Sverchok panel, you can import the JSON file into your definition here. All right. So let's go ahead and get started. Delete the default cube as we usually do, and let's create our first three primitives. So let's create a prism, a cylinder, and a sphere. So Topologic has a prism and a cylinder, so we can at least use those very quickly. You can create them any way you want. There's not a problem there. So we'll have a prism here. Let's see if we can get the cylinder as well. So you have to choose cell.cylinder, which is this one. Let's go ahead and create a blender sphere and convert it. So we have a blender sphere here, and we'll do a topology.geometry. And sorry, not topology.geometry. I'm confusing myself. Topology by geometry. And we get the vertices, the edges, and the polygons become faces. It's the same thing. And if we, as usual, control click on these, you'll notice that it is a cell. And those will be cell as well once we create them. Okay, so let's go ahead and visualize them because we need to move them. So we're going to put a translate node in order to move them around. So again, translate. So this is topology.translate. We probably don't have to move the prism. So we're going to make that the lower left corner, but it's important to see it. So let's go ahead and do a topology.geometry on it, and control click to see where it is. So this is the cube, right? So we can take these and I'm going to not do the faces so that I can just see it as a wireframe. And let's go ahead and take a look at the cylinder, make another topology geometry. Oh, the cylinder is quite big, so let's go ahead and change the radius to be 0.5 and maybe change the height to be 1.5. Okay, that's pretty good. Maybe move it a little bit, so I'm gonna translate it in the X 0.4 maybe. Oh no, that's the wrong axis. Let's keep that as 0. Change it in the Y 0.4. Oh no, okay, so minus 0.4. I'm just gonna move it that way. Maybe that's too much. So minus 0.25. Maybe I shouldn't move it at all because I'm gonna intersect it with the sphere. So I'm gonna keep it, sorry about that. I'm changing my mind all the time. Minus 0.2 here. Okay, that's absolutely fine. I think we'll get some kind of intersection. So that's the cylinder. Let's take a look at the sphere. So again, let's copy this over, get rid of this one and just feed it the topology itself. And here is the sphere, so we need to move that as well. So let's actually go ahead and put a translate on it before. That's a nice feature of Sverchok. We can do that. And let's see, where are we moving it here? So we're gonna move it in the Y minus 0.5. In which direction? No, so we have to go the other way. Perhaps 0.75. And let's take a look. Maybe a little bit more. Maybe we'll reduce the radius as well. 0.5. It'll take a while. Maybe that's too little. 0.75. Okay. Maybe we should lift it up in the Z. So we'll lift it up 0.75 in the Z. And let's move it some more. Okay, that's fine. That took us a while, but we got there. Does it intersect with the cylinder? Yes, there should be good intersections between the three. I'm just trying to get them so that they all intersect in different ways. Fantastic. So we have them here. So what we can do now is, I'm going to delete these a bit later, but for now I want to show you how to create a dictionary and set them to each one. So let's go ahead and get started with that. So we have a dictionary by keys values. So a dictionary is basically a data structure. Basically it's a kind of two lists that are coordinated. You can think of it that way. It has keys and attributes. So in a company, you might have first name, last name, salary, age, position, and you will have values for each of these type of keys. In this case, we're going to create a dictionary that has a key that's called ID. You can call it whatever you want. We're going to call it ID. And a value that is going to be called prism in one case, cylinder in another case, and a sphere in the third case. So if we do by keys values, we find something called dictionary by keys values. And the nice thing about it here is that you can just type them immediately into this text field. So I can type ID here, I can type prism here, and I can make copies of this, 2 of them. And this is, I'm going to call cylinder, and this one I'm going to call sphere. All right, let's move them to the right location. So this is going to go to this one, this is going to go to this one, this is going to go to the cylinder. So now how do we assign this dictionary to the cell? There is something called set dictionary. So we look for set dictionary, so topology.set dictionary. And again, we need 3 of those. Great. So all we need to do is feed it the original cell and feed it the dictionary. And then again here, same thing. After we have translated it, probably it's a better idea. Oh, sorry, that's not it. It should go to here. And this should go to here. And also this one. And this one. Great. So if we check these just to make sure we have them, that's a cell, that's good. That's a cell, as you can see, and this should be also a cell. Great. So now we have these 3 cells. Let's make a list out of them. So list join, and we feed them into the data ports. So now we have a list of 3 cells. Again, you can check that. You can see here 3 cells. And we can now build a cell complex out of them. So let's go ahead and do a cell complex by cells. And control click that, and we have a cell complex. Now, unlike Topologic in Dynamo and Grasshopper, when I was designing it for Blender and Sverchok, I decided to change how dictionaries are being transferred. So instead of cell complex by cells automatically transferring the dictionaries, because to be honest, in Grasshopper and Dynamo, the implementation of that in C++ is not robust, has a bug in it, and sometimes the dictionaries don't transfer correctly. There are some edge cases where they don't work. So I decided to rewrite that completely and make it as robust as possible in Python. So I have created a new node in Sverchok called transfer dictionaries from sources to sinks. And it's a lot more robust, and you can have a lot more options on it. So that's the beauty of Python, in the sense that if you're not happy with the source code, you can write something on top of it, use some of the source code that you are happy with, and then add more functionality. And then you create a brand new node that has really interesting features. So let's take a look at that. So that's called transfer dictionaries, and it's really powerful, because what you can do is give it any list of sources, a single sink, which is like a cell complex. You can give that, and you can then decide what you would like to transfer. Do you want to transfer the vertex dictionaries, the edge dictionaries, or the face dictionaries, or the cell dictionaries? These are your options. You can transfer all of them, so you can have a very rich topology that has dictionaries at all levels. Now, in this example, only the cells have dictionaries, so it doesn't make sense to spend time trying to transfer vertex, edge, and face dictionaries. So we're going to turn those off, like that. Now the sources, what are the sources? The sources are basically the list that we have created, these things. So if you, again, if you control click on that, to remind you, this is a list of the 3 cells and they have dictionaries in them. If I'm not mistaken, right here, set dictionaries, set dictionaries, set dictionaries. So we can go ahead and feed that in as the sources. And then the cell complex is the sink. And we should have now a cell complex as the result. But those cells in this cell complex have these dictionaries built in. And they will last forever. Now, you could say, well, what's the big deal? Why don't we just get the dictionaries from the original cells and just display those? Well, the interesting part of it is that if you remember, the cell complex now has multiple cells, more than 3, right? It has about 5 or 6 cells. And those new cells that have been created automatically will have in them the correct dictionary that says, oh, which parent or parents did I come from? So it does all that tracing, almost like a DNA tracing of the parents back into these new cells that have been created. And that's the power of transfer dictionaries. So let's go ahead and take a look at that. So let's go ahead and do subtopologies, topology.subtopologies, and let's get the cells out of the cell complex, this new cell complex, and let's find out how many cells we have. So again, control click on it, and we notice here that we have 1, 2, 3, 4, 5, 6, 7 cells. That's quite a bit. So let's go ahead and get each cell at a time and examine its dictionary. Oh, sorry, I keep doing that all the time. Right, so Alt space in order to do a list item, and we'll operate on level 1, and we get the data in here, and we can take a look at the item. So we're going to do topology.dictionary. So we're going to get the dictionary of this cell, and then we're going to do value at key. So value at key, basically, you give it a key, which is ID. That's what we know, that we have created a key called ID, and it will give us back the value at that ID, or at that key, excuse me. So the key is called ID. The dictionary, we feed it in from here, and we take a look at the result. All right. So it is telling us that this cell that we created at index 0 has an ID of prism cylinder. So let's check that visually. So we have the cell here, this one. It's item 1 here, index 0. Okay, so let's go ahead and do a topology.geometry in order to visualize it, and control click to get a quick preview of that. And as you can see here, it's highlighted in blue. So if you look at that, and I should really copy that over, sorry about that, because it reuses the same node, so you cannot really see the cell complex or the original prism. So let's go ahead and go back here and connect these so that we can see them. Okay, so that's the original prism. All right, so let's get back to our cell here. So you'll notice, and let me make this larger so that you can see it clearly. You'll notice that this cell is the intersection of the prism and the cylinder, and has nothing to do, or it's outside the sphere. So the sphere does not affect it. All right, let's exercise that. Let's get index 1. So this one obviously is just the cylinder, right? Exclusive of everything else. And let's go one more. This is exclusively the prism. This is now all 3 of them together. So you'll see here it is the prism, the cylinder, and the sphere. And then you can make kind of spatial decisions based on that, right? So you know that this space is the intersection of these three parents. It's then up to you to decide what you would like to do with that space, or how you'd like to treat it, how you'd like to express it. So it could be quite powerful. And this one is the cylinder and the prism. Sorry, it's the cylinder and the sphere. You can see how it is outside the prism, and so on and so forth. So this is the prism and the sphere, but not the cylinder. Right, so that's it. In the original definition that you'll see on GitHub, I've added a bit of bells and whistles where I take the names from here and display them onto the screen. I'm not going to waste your time with that. It's just a display issue. But if you'd like to examine this definition, head over to GitHub, download it, and try it out for yourself. Thanks for watching.